Hi everyone, welcome to
amazing channel of brilliant Qatar.
In a circuit, cells can be connected in series or in parallel. So in which case we'll be getting more current, a maximum current.
halogen connected carbon sp3, then it's connected to benzene ring. See all of you, halogen connected. What is this carbon hybridization? Full single bond sp3, see then a benzene ring.
Denominator poles shouldn't be included in the denominator poles. That means the denominator, these -1 and -5 should never be included in the solution.
Homocircle caudal fin. It's giving two equal lobes. But in case of cartilage fishes, look at here, one big lobe is there, one small lobe is there. You cannot cut into two equal half this fin.
Qatar.
Good evening all. Welcome to another live session of MCQ discussion of class 10th. I hope yesterday you have done already 2 sessions. Now today we are going to discuss a very important chapter in chemistry, which is carbon and its compounds. So before we begin, let me just confirm those who are attending this live, am I audible? Can you all hear me clearly? Could you please respond in the chat box so that we can start? Yes, Padmavashan, hi, good evening. Okay, right. So I believe you all are ready to attend the board examination. Now these sessions are just reinforcing the knowledge what you have gained in the last year. So you all might have already finished revising the NCERT textbook and the theory contents in that, and you have made your own wonderful notes. You have written enough mock examinations in Brilliant, and your confidence level should be really high by now. So with these MCQ sessions, it will be boosted much higher, so that everybody must aim to get full score in science examination. So carbon and its compounds is a very important chapter. As you know, it is not only important for 10th standard, it is the basics or the foundation for the organic chemistry modules which you are going to have in 11th and 12th for those who are taking science. So in this session, I will be going through some of the most important MCQs which are as per the latest CBSE examination scheme. So you can see question number 1. The formula of 4 organic compounds are shown below. Choose the correct option. See, in MCQ questions, it's very easy to score the marks in that, and at the same time, if you have a little bit of carelessness, the whole 1 mark will be gone. So you need to be really careful and very much focused on reading the question as well as the options. So look at this list of 4 compounds given here. You can see in this compound A, which is CH2 double bond CH2. Who can tell me what is the IUPAC name of this compound? Come on, I'm waiting. What is the IUPAC name of the first compound? Come on, it's a very simple compound. You all know what is the 2 carbon containing unsaturated hydrocarbon with a double bond. Yes, perfect. I can see most of you are answering the correct option. Yes, Anushay, Padmavarshan, Shabnur, Samir, Asfar. Very good, very good. This is ethene, which is a unsaturated hydrocarbon, and it's an alkene. Now, what is second compound? What is compound B? CH3COOH. Yes, you can see that this functional group C double bond OOH is called as carboxylic acid, isn't it? So this is a 2 carbon containing carboxylic acid, and it is known as ethanoic acid, commonly known as acetic acid, the main component that you see in vinegar, right? Now we have compound C. What is compound C? Compound C is a saturated hydrocarbon with single bonds, and there are 2 carbon atoms. So this is ethane. And then compound D, we have CH3CH2OH. You know that OH is a functional group which is called as alcohol, and there are 2 carbon atoms. So the parent chain is eth. So this alcohol is ethanol. So we have identified all the 4 compounds. Now we'll read the options. A and B are unsaturated hydrocarbons. See, you can see that A is an unsaturated hydrocarbon, but B is a carboxylic acid, and you can see that there is only single bond between carbon atoms. So it's a carboxylic acid, it's not a unsaturated hydrocarbon. Then C and D are saturated hydrocarbons. See, again, C is a saturated hydrocarbon, D is an alcohol. Then option C says addition of hydrogen in presence of catalyst changes A to C. What is A? A is ethene, and what is C? C is ethane. So ethene is converted into ethane by adding hydrogen in presence of a catalyst. Don't you think that option is correct? Because we have studied one of the main chemical properties or chemical reaction in hydrocarbons, which is called addition reaction or hydrogenation reaction, which is a reaction where we add hydrogen in presence of catalysts like nickel, palladium and platinum to convert it into saturated hydrocarbons. So option C is a correct statement. We'll read option D also. Addition of potassium permanganate changes B to D. See, B is a carboxylic acid and D is an alcohol. You have studied a reaction called oxidation of alcohols, right? Oxidation of alcohol means alcohols can be oxidized in the presence of an oxidizing agent like alkaline potassium permanganate or acidified potassium dichromate. These 2 are 2 of the best oxidizing agents in organic chemistry. So by using this oxidation reaction, we can oxidize an alcohol into acid, but here it says B is converted into D, which is wrong. An acid can only be reduced to alcohol. You cannot oxidize an acid anymore into an alcohol. So this option is wrong. So the correct choice would be C. Right. Now let's go to the second question, which is structural formula of ethyne is. See, ethyne is the first member of the homologous series of alkynes. You know that alkynes are hydrocarbons which have at least a triple bond between carbon atoms, and the first member of the alkyne family is ethyne. And what is the formula of ethyne? Ethyne is C2H2. We have a triple bonded carbon atom, and the remaining valency is satisfied by hydrogen. So which option is correct among these 4? It is CH, triple bond CH. Right, perfect. Now, if you all remember the general formulas of these hydrocarbons, what is the general formula of an alkane? Alkanes are having CnH2n plus 2, where n is the number of carbon atoms. So if if they ask you what will be the formula of an alkane which has 16 carbon atoms? Come on, what will be the formula of an alkane which has 16 carbon atoms? Yes, come on, quick. You can apply this formula and put n is equal to 16. So it will be C16, H2 into 16 is 32, plus 2 is H34. So by knowing the general formula, we can predict any formula of the alkane or alkene or alkyne right? So alkenes have a formula CnH2n, and alkynes will have a formula of CnH2n minus 2. So these are the general formulas of all the hydrocarbons. So it is very easy to predict the formula, molecular formula of any hydrocarbon, whether it is an alkane, alkene, or alkyne. Right, that was an easy one. Now the next question, the name of the compound CH3, CH2, CHO. See, definitely you're going to get one question related to IUPAC nomenclature, especially that with functional group. So everyone are supposed to identify the functional groups clearly. As you know, this functional group OH, this is known as alcohol. Then if you have a halogen attached, this halogen can be fluorine, chlorine, bromine, or iodine. Then such compounds are called as haloalkanes. And then we have C double bond O. Remember, this functional group is a very important functional group. You can see that there are two valencies for carbon, and both the valencies has to be satisfied by carbon atoms itself, and that is forming the family called as ketones. And that is a very same reason why we say that the ketone family starts with minimum 3 carbon atoms. And you all know the first member of the ketone family, and that is propanone, right? Then we have C double bond O with one valency satisfied by hydrogen, and that group is called as aldehyde. Many a times I have seen that students make a mistake in identifying ketone and aldehyde. So don't make that mistake. Ketone is C double bond O, where the carbon is flanked by carbon atoms, whereas aldehydes are CHO groups. And then we have one more group, which is COOH, and that is known as carboxylic acid. Carboxylic acid. And especially when they give you the name of the compound and ask you to draw the structure, there is one common mistake that everybody does, and that is especially with these 3 compounds, ketones, aldehydes, carboxylic acids. You see, if they ask you a question, draw the structure of butanol. Draw the structure of butanol. See, butanol is a compound where there is 4 carbon atoms. So most of the times what the students do is they put 4 carbon atoms framework, and then what happens next is these 4 carbon atoms, apart from these 4 carbon atoms, since it is an aldehyde, I have seen many times that the students add an aldehyde group. But this is wrong, because there are 5 carbon atoms now, and it has become pentanol. It's not butanol. So every time when you have a functional group with carbon, make sure you don't increase the number of carbon atoms. Just make the necessary changes in the functional group of the particular compound. So this is the structure of butanol. So this is a common mistake that some of the students make. So be careful with this. It shouldn't cost the full marks in science. So please be careful with this. So now in this question, CH3, CH2, CHO, it is very easy. You have 3 carbon atoms total, and there is an aldehyde group. So what is the name of this compound? This compound is, come on, yes, propanol. Excellent, propanol. And you know the structures of the other compounds. Propanone is the first member of the ketone family, CH3COCH3. Then ethanol is CH3CH2OH, and then we have ethanol, which is CH3 C double bond OH. Clear? So I hope all of you are confident enough in writing the structures of the functional group containing compounds. Okay, perfect. Next question. Which of the following represents saponification reaction? A very important chemical reaction in carbon and its compounds, I would say. You have studied esterification and saponification. What is esterification? When a carboxylic acid is treated with an alcohol in the presence of an acid catalyst, an inorganic acid catalyst like sulfuric acid, we get a fruity smelling compound, and that compound is known as ester, right? And these esters can be broken down again by using acid catalyst or alkali. Especially when we use an alkali like sodium hydroxide or potassium hydroxide, what we see is the ester breaks down itself into the corresponding sodium or potassium salt of carboxylic acid plus the alcohol. And this reaction is mainly used in the preparation of soaps, because you know that the definition of soaps, as what you learned in the textbook, is soaps are sodium or potassium salts of carboxylic acids, right? So to make soap in industrial scale, we use the saponification process. And remember, saponification is a highly exothermic reaction. What do you mean by exothermic reaction? A reaction which liberates a large amount of heat energy. Right. So let's go through each reaction here. The first reaction is CH3CONA plus NaOH gives CH4 plus Na2CO3. This reaction is something which you didn't study till now. This is a reaction from 11th standard. It's called as decarboxylation reaction. It is a reaction used for removing carboxyl group from a sodium salt of carboxylic acid and make an alkane out of it. You can see that methane is the major product here. So this reaction is called as decarboxylation. Anyway, it's not saponification. Now the second one is CH3COH plus C2H5OH in H2SO4 giving CH3CO C2H5 plus H2O. What is that reaction? This is called as esterification. An ester is made from a particular carboxylic acid and an alcohol. And I believe all of you know how to name the esters. So let's take this example, CH3COO C2H5. You know, naming of esters is very easy. Every ester is named by a general method called as alkyl alkanoate. Alkyl alkanoate. And you know, I'll tell you the easiest way to do this. Alkyl, this part is coming from the alcohol, because every ester is made by the reaction between alcohol and carboxylic acid. And then alkanoate, this part is coming from the acid. So can you try what will be the name of this particular ester? You know that this ester is produced from an alcohol called ethanol, right? And a carboxylic acid called ethanoic acid. So how do we apply this rule? The alcohol is ethanol, so we'll write the name as ethyl, and then the acid is ethanoic acid, so we'll write the name as ethanoate. Ethyl ethanoate. That's really easy, right? So that's how you name the esters. Okay. Now the next one, CH3COH plus Na gives CH3CONA plus H2. This is just a simple displacement reaction where we have a metal and you have an acid here, and you have studied in the chapter acids, bases and salts that when metals are added to acids, it's going to displace hydrogen and you get salt. So that is also not saponification. Now look at the last reaction. The last reaction is an ester is treated with an alkali and you get sodium salt of that carboxylic acid plus alcohol. And that reaction is what is called as saponification, which is used for the preparation of soap. You know, in the textbook, they have given this example as a molecule of soap. But remember, this is not the real soap molecule. Real soap molecules have a similar architecture. And the real soap molecules are having many number of carbon atoms in its chain. Say for example, you have a soap molecule which has a formula like this, CH3 CH2 14 times COONA. This molecule is known as sodium palmitate. This molecule is known as sodium palmitate, and sodium palmitate is a real soap molecule. So soaps are sodium or potassium salts of long chain carboxylic acids. Is it clear to everyone? Okay, perfect. Right. See, I request every one of you who are attending this live session to carefully listen to what I am teaching, because at the end of this session I am going to conduct a quiz and I am going to announce the winner at the end of the quiz. So I want your complete attention here. Each and every minute points which I am mentioning here is really important. Okay. The next one, which of the following is not observed in a homologous series? Give reason for your choice. Okay, coming to homologous series, that's something which is frequently asked in board examination, you know, be it the definition or be it the examples. There are so many times this question has been repeatedly asked in boards. A homologous series is a series of carbon compounds where they have the same functional group, but they differ in the number of carbon atoms. And each adjacent member in a given series will be having a difference of one CH2 group or a atomic mass of 14 units, because one CH2 is having a mass of 12 plus 2, which is 14 units. So this is what is called as homologous series. And you guys know that for any compound, its chemical property is mainly dependent on the functional group that it possesses. For example, we say that all the alcohols, they exhibit similar chemical reactions. Why? Because all what they have in common is an OH group. So that OH group is the reason why they show that reaction. Every carboxylic acids have the same kind of chemical properties. Why? Because all of them are having the same functional group, which is COOH. So this is one unique feature of homologous series of compounds. That is, they all have the same chemical property because they have the same functional group. So remember that point. And second point is, if you take the members in a given homologous series, their physical properties are not going to be the same. For example, if I take methanol and ethanol, you know, they differ in their boiling points. Why do they differ in their boiling points? Because physical property is not dependent on the functional group. It's dependent on the carbon chain, the length of the carbon chain. Say, for example, ethanol has 2 carbon, whereas methanol has only 1 carbon. So there is less surface area for methanol, there is more surface area for ethanol. So the intermolecular force of attraction, which is the main factor that decides the boiling point, is more for ethanol. That's the reason why ethanol has higher boiling point. So if I take propanol, it will definitely have a higher boiling point than ethanol. So remember, physical properties are different for homologous series, but chemical properties are going to be the same. Now, based on these ideas, can you select the right choice for this question? Which of the following is not observed in a homologous series? The first option itself is wrong, isn't it? Change in chemical properties. That's not true, because every homologous series compounds will have the same exact chemical property because it is decided by the nature of the functional group. Is it clear? Okay, perfect. Most of you have given the right answer here. Utkar, Sheikh, Abdul Wadud, Praveena. Yes, perfect guys. Really good. Keep up the spirit. Yes. Let's read the other options as well. Difference in CH2 and 14 units molecular mass. That's true. Then gradation in physical properties. Yes, that's true. Gradation in physical properties means physical properties are gradually varying. Right? I told you, boiling point, melting point, these are all going to be different for them. Then same functional group, that's also true. That is what is called homologous series. So I believe this question is clear to everyone. Right. Excellent. So I can see the active participation of you guys in this session. Keep up the same spirit. The next question. Ethane with the molecular formula C2H6 has. See, already we talked about ethane. Ethane is a saturated hydrocarbon which has only 2 carbon atoms. So we put 2 carbon atoms and then we have the remaining valency satisfied by hydrogen. So CH3 single bond CH3. This is what is ethane molecule, right? Now they asked how many covalent bonds are there? So you can see that there is 1 covalent bond here, 2nd here, 3rd here, 4th here, 5th here, 6th and 7. So altogether there are 7 covalent bonds in this. Is it clear? Perfect. So 7 covalent bonds. Right. Okay, great. Now going to the next question. CH3 CH2OH in presence of alkaline KMNO4 and heated gives CH3COOH. In the above given reaction, alkaline KMNO4 act as. Come on, a very important question. We already talked about this, right? I told you that alcohols can be oxidized to carboxylic acids, right? So what is the role of alkaline KMNO4 here? Alkaline KMNO4 is acting as the oxidizing agent. And if you remember, if you recollect the definition of an oxidizing agent, a substance that adds oxygen to a starting compound, and that is what exactly we see here, right? CH3 CH2OH, and it becomes CH3COOH. So this hydrogen is removed and oxygen is added, and that is what KMnO4 did here to ethanol, and that's how ethanol became ethanoic acid. So the function of KMnO4 here is it is acting as an oxidizing agent. And I would like to add on one more important information in this question. Sometimes they ask you, how do you distinguish between ethanol and ethanoic acid? See, you can write this as an answer, because ethanol is oxidized by KMnO4, but ethanoic acid cannot be oxidized. So if you have two test tubes where one is ethanol and one is ethanoic acid, and you don't know which is which, you add KMnO4 into it, or you can add K2Cr2O7 as well. These are two oxidizing agents. So the tube where ethanol is there will undergo oxidation, and what will happen is, this KMnO4 and K2Cr2O7, they both are colored compounds. So when you have a reaction where ethanol is present, that oxidizing agent is being consumed. So there is no more of them. So in the tube where you have ethanol, the color of KMnO4 and K2Cr2O7 is gone. So decolorization of KMnO4 or K2Cr2O7, that indicates there is an alcohol, and if the color is retained, then that's a carboxylic acid. A very simple and a very important test to distinguish between alcohol and carboxylic acid. And in fact, you have one more test where carboxylic acid answers the test, but ethanol doesn't. For example, you add sodium bicarbonate or sodium carbonate, a metal carbonate or a metal bicarbonate. When you add into any acid, what will happen? There will be formation of salt, water, and carbon dioxide. And that carbon dioxide is going to bubble through the solution, and it creates a brisk effervescence, right? So when you have a brisk effervescence in the tube, then that's going to be surely an acid. And where you don't have a reaction, that's an alcohol. So I'm sure all of you understood the two different tests which I told you that can distinguish between alcohol and carboxylic acid. Is it clear, guys? Okay, excellent. See, these are all conceptual questions. All you have to do is, you need to have a proper understanding on the subject. And then, you don't have to worry about, mugging up things, by hearting all the reactions. You can instantly make the reactions, be it any compound that they give you, because you are studying the general reactions and the mechanisms in 10th standard. So if that has been learned in a proper way, then you can easily answer these questions. Because maybe tomorrow in the exam they might not ask you about this ethanol to ethanoic acid. Instead they will give you propanol to propanoic acid. How do you convert it? Same reaction, because any alcohol can be oxidized into the corresponding carboxylic acid by using these oxidizing agents. So like this, if you understand and study, it's going to be a very easy job. Right. Let's go to the next question. The correct electron dot structure of water molecule is? Yes, water molecule. So in H2O, you know that oxygen is the central atom, right? And then we have hydrogens around it. Now, oxygen is an element which has 6 valence electrons, right? Oxygen has 6 valence electrons, and hydrogen has 1 valence electron. And you know that where there is no possibility of losing or gaining, sharing is the only option, right? So if you take oxygen's case, oxygen is in requirement of 2 electrons, whereas hydrogen is in requirement of 1 electron. So let's assume that hydrogen's valence electron is this, and oxygen is going to share 1 electron with each hydrogen, and the remaining 4 electrons will go unshared. This is how the covalent molecule called water is formed, right? So this is how you draw the electron dot structure of them, and here you can see that the main idea behind this sharing is that once shared, every one of them have equal claim on what they have shared, isn't it? It's not like losing or gaining, where one guy is giving the electron permanently to the other one. This is a sharing. It's like a mutual coexistence. So at that time, how much ever electrons they have put in the sharing, it's like a business. They get equal shares on both of them. So if you go and ask this hydrogen, how many electrons do you have now? It will say, I have 2 electrons, I am happy. That's all hydrogen needs. And then the same thing applies to this hydrogen as well. It is also having 2 electrons. Now we have oxygen. Oxygen has made the sharing in such a way that it is now having octet. It is now having 8 electrons around it, right? So this is the molecule called as water. And if they ask you how many bonds are there in water, do not say it's a double bond. It is 2 single covalent bonds, right? It is 2 single covalent bonds. So what is the right option here? Okay, most of you have said it is C. So in C we have 2 bond electrons. Yeah, C is the right choice there. So I hope everybody know how we got the answer as C. You should count each dot, okay? We are not randomly putting the dots. It's based on the number of electrons in the valence shell of each atom. Right. Okay, great. The next question. When sodium hydrogen carbonate is added to ethanoic acid, a gas evolves. Consider the following statements about the gas evolved. See, I told you about this reaction as a test to distinguish between acid and alcohol. You remember? So ethanoic acid is CH3COOH. And you are adding sodium hydrogen carbonate, which is NaHCO3, commercially known as baking soda, right? So when you add it, you get CH3COONA plus H2O plus CO2. And this is the gas that is released during this reaction, right? And I told you a qualitative observation that you see here. It's called brisk effervescence. When a gas is released through the solution, that sparkling effect that you see is called as brisk effervescence. Now, they have talked about the characteristics of this gas. It turns lime water milky. True, right? Carbon dioxide is a gas which can turn lime water milky. Why? Because carbon dioxide, when passed into a clear solution of lime water, an aqueous solution of lime water, it is going to react and give you calcium carbonate, which is insoluble in water, and it creates a milky white coloration to the solution. That is called lime water test. And I bet all of you know what will happen to this lime water which has turned milky if you pass excess carbon dioxide to it. It will once again become clear due to the formation of calcium bicarbonate, right? Yes. So it turns lime water milky. Yes, indeed it's true. It is evolved with a brisk effervescence. That's true. It has a smell of burning sulfur. No, it is not sulfur dioxide. It is carbon dioxide. It doesn't have a characteristic smell. It is also a byproduct of respiration. Very much true, because aerobic respiration liberates carbon dioxide, right? You have studied that in the chapter life processes, where when glucose enters into the cells after digestion, it gets absorbed into the bloodstream, and the blood will deliver it into the cell cytoplasm, and then the glucose will break down into pyruvate, and then the pyruvate is broken down into carbon dioxide, water, and energy. So carbon dioxide is indeed a byproduct of respiration. So A, B, and D are the correct statements. Yes. So option D. Yes. Yeah, most of you have answered it correctly. Excellent, excellent. So I think we can move on to the next question. While studying saponification reaction, what do you observe when you mix an equal amount of colorless vegetable oil and 20% aqueous solution of NaOH in a beaker? Come on. Those who have listened to my explanation previously can easily answer this question. We are adding vegetable oil into, and NaOH is added into it. You know, vegetable oil is a source of fat, right? Oil or fat. That is what is the prerequisite of saponification reaction, because oils and fats are esters. They are esters of fatty acids and glycerol. So it's an ester, and to an ester you are adding NaOH. NaOH is a base, so that reaction is same as saponification. So the option says the color of the mixture has become dark brown. No, there is no color change happening there. A brisk effervescence is taking place in a beaker. No, because there is no gas released there. The outer surface of the beaker has become hot. Yes, because saponification is an exothermic event. And you remember I told you about this in the beginning. So since it is an exothermic event, it will make the beaker surface hot. So that will be the right answer. Yes. So let's move on to the next question. This is an assertion reason question. Assertion says, following are the members of a homologous series CH3OH, CH3CH2OH, CH3CH2CH2OH. So is that statement true? You can see the given molecules are, this is methanol, this is ethanol, this is propanol. As long as they have the same functional group, and that is here in this case it is alcohol, OH group, they belong to the same homologous series. So that statement is true. The reason given is a series of compounds with the same functional group but differing by CH2 unit is called a homologous series. A series of compounds with the same functional group but differing by CH2 unit is called as a homologous series. That's true. And that is indeed the reason why they are in the same homologous series, right? So here both these statements, both assertion and reason are true, and reason is the correct explanation of the assertion. So it's option A, right? Option A, perfect. Yes, very good, very good. Okay. The next question. Following are the structural isomers of butane, and you have a set of compounds given there, and you have to look at those compounds and say if they are structural isomers of butane or not. Look at the first compound. The first compound is CH3, CH2, CH2, CH3. It is butane, right? It is normal butane, the straight chain of 4 carbon atoms. That is butane. So it is an isomer of butane. The second compound is CH3, CH, CH3, CH3. It is a branched isomer, isn't it? You have studied butane has a branched isomeric form which is called as isobutane or 2-methyl propane. Correct? Isobutane or 2-methyl propane. So they are isomers. And the reason that they have given here is structural isomers have the same molecular formula but they differ in their structures. That is true. Structural isomers have the exact same molecular formula. For example, butane has C4H10 as the formula, and they are differing in their structures. One is a straight chain isomer, one is a branched chain isomer. Is it clear to everyone? Yes, so it is option A. Yes, Praveena, Hamdan, very good. Yes, both A and R are true, and R is the correct explanation of A. Next one. Esterification is a process in which a sweet smelling substance is produced. Is that true? Yes, Rahul is saying it is true. Okay, let's take it true, because esterification is the process where a sweet smelling substance called ester is produced from carboxylic acid and alcohol. The reason given, when esters react with sodium hydroxide, an alcohol and a sodium salt of carboxylic acid are obtained. The statement in that reason is actually true, right? Because when esters react with sodium hydroxide, you get alcohol and sodium salt of carboxylic acid. That's called saponification. So the statement is actually true, but is it the correct explanation of the assertion? No, it's not. So it is going to be option B. Assertion and reason statements are true, but it is not the correct explanation of the assertion. Yes, perfect. Okay, great. Very good. So those who are answering in this chat box, I am sure you have done your revision part really good. Let's see how you will perform in the quiz. Next, which of these is a saturated compound in which 6 carbon atoms are arranged in a ring? Which of these is a saturated compound in which 6 carbon atoms are arranged in a ring? See, 6 carbon atoms in a ring. Every ring compound will be starting with a prefix called cyclo, right? And 6 carbon atoms. The word root for 6 is hex, correct? So we can straight away cut down these two options, hexane and pentane. That cannot be, because they are straight chain hydrocarbons. Now we have cyclohexane and cyclopentane. Cyclohexane has 6 carbon atoms and cyclopentane has 5 carbon atoms, right? So this is cyclohexane and this is cyclopentane. This is the bond line method of representation of the compounds, okay? And one common error that I have seen is that sometimes, when they give you the diagram of cyclohexane, students have a tendency to pick it as benzene, because that's only 6 carbon aromatic hydrocarbon you have studied. So that's a small point, but still significant. Don't get confused between cyclohexane and benzene. Cyclohexane is having saturated carbon ring, whereas benzene has at least 3 carbon double bonds which are alternating with each other, and its formula is what is benzene's formula? It is C6H6. So this is the structure of benzene. We have C6H6 and cyclohexane will have C6H12. Clear? And I'm sure everybody know how to draw the complete structural formula of this. Here I have not shown the carbon and hydrogen atoms. It's just the bond lines which I have represented. But if they ask you to draw the complete structure, just expand it. That's it. If it is benzene, you just put all the carbon atoms here, and each carbon has one hydrogen. Clear? Sometimes if they ask you to draw the electron dot structure, that's again very easy. Each single bond is 2 electrons. So erase one bond, put 2 electrons. Finished. Is it clear to everyone? Okay, great. So I have seen that you are answering pretty well, and there are some of them who is not answering, who is not sharing any answers. There are around 80 students who are watching this live, but still I see only few names frequently coming. Okay, for those who did not answer the questions in organic chemistry, I have some interesting questions for you. If you are a Marvel fan, I'm sure you can answer these questions. Come on, here you go. I have 4 questions here. 3 with pictures and 1 with statement. First question. What is Tony Stark's final line in the first Iron Man? What is the answer? I have 3 options. Avengers assemble. I am Iron Man. I could do this all day. Come on. Let's see who answers this. Okay, Rahul is saying it's B. I am Iron Man. Aswar is saying it's B. Okay. The answer is I am Iron Man. Okay, Samir is saying B. Okay, Samir, I think you were not answering the organic chemistry questions till now. But anyway, I'm happy you answered this. The next question, what is the name of Tony Stark's AI assistant who becomes the basis of the vision? Is it Homer? Is it Jarvis? Is it Alfred? Okay, most of you are saying the correct answer. It is Jarvis. What fictional alien metal gives the Wakandans their power? Is it vibranium? Is it adamantium? Or is it unobtainium? Okay, see. The reason, even the last question also, maybe for your reference, you can just check. What kind of food does Tony Stark suggest the Avengers eat after saving New York in the Avengers film? Is it burritos? Is it pizza? Is it fondue? Or is it shawarma? And I'm sure that, by now, every one of you might have, those who have watched, okay, maybe some of you haven't watched these films, but still, you know, some of you might have watched and you were able to answer all these questions correctly. See, you might be thinking that in between chemistry, what is this guy doing with all this Marvel stuff and all? See, there is a reason why I wanted to put up this slide in between this discussion, because you are going to write the board examination, right? And by now you might have finished all those revision sessions with your teachers. You have written enough mock examinations. Your confidence level will be very high. I know that. But you know, still, if you want to reach that 100% potential, if you want to unlock your 100% potential, you must understand that you are going to write this examination for a reason. And you must strongly believe that in this examination, I'm going to put all my efforts and I'm going to get a really wonderful result for all the preparations that I have done so far. See, our thoughts has a great impact on the realities that we see. Because many of us, I'm not saying that it is only for students, including me, every human being has a problem. The problem is that they anticipate the results in future based on what they have experienced in the past. They never think about all the probabilities in the present. For example, in your 10th standard, maybe when you started this academic journey and your school teacher has asked you a question in chemistry, what is the valency of carbon, and accidentally you got it wrong and you told it is 6 instead of 4. And you know, your friends might have laughed at you. That past, whatever happened in the past, might have created a fear in your mind that, okay, I'm not good in chemistry. Something has gone wrong. I will not be able to do chemistry. Even, you know, in my last revision classes, I had an incident where when I asked about the students, that one guy was saying that chemistry is hard, biology is very easy. I need to sit for chemistry. Maybe, you know, he might be leaving a smiley by now if he is in this session. But still, you know, this is something really important, guys. Physics, chemistry, biology, all these 3 subjects can be easily done if you really know why you are taking up these things and why you are going to appear in the board examination, what for you are writing, why you want to really score good marks. If this clarity is there in your mind, then only the results will come. No matter how much ever times you read NCERT textbook, 5 times or 6 times or 7 times, or you ask your teachers to send more and more worksheets, more and more sample papers, it's not going to do that. You're not going to get that benefit unless and until you appreciate yourself that, you know, I can do this really well. Because the same way how you watched a movie and you remembered all those dialogues and all those characters and all those code names, everything which I just demonstrated before, you should remember that you are having that potential. But why this potential is not coming up is, it's your thoughts that is molding up your reality. So your thoughts has to be changed. You can't sit in a room and simply sit in front of the books showing your parents. Even I have seen many parents coming to us and telling that, you know, my child is not improving, my child is not getting marks. Remember that this is actually there is a small correction that you have to do in your daily routine which will tremendously improve your results, and that is your perspective towards studies. Change that perspective from today. Your thoughts can mold your realities. Your thoughts, if it is positive, you will see positive outcomes. I have experienced it in my life. That's the reason why I'm telling you continuously that this is something which has to be done. I know that this is taking up a little time, but I'm sure, you know, without saying this, as a teacher, I will not be doing justice to myself, because I can discuss hundreds of MCQ questions today and wind up the session. But without telling you this, it's of no use. Now from next slide onwards, you know, with this perspective, with a positive mindset and thinking that, you know, the exam is going to be really easy, I'm going to rock this exam, I'm going to get full marks in this exam, you will see that the question paper will become easy. You will see that your answer evaluation, the person who is evaluating your papers will keep on putting marks. These are all going to manifest positive things in your life if your attitude is right. Otherwise, with a negative attitude, oh man, I did not prepare physics this chapter. I'm just fed up with this sign conventions. I'm fed up with this chemical reactions. I can't remember a formula. you keep saying this to yourself. The more you say, your mind will take this as a command and your body will act according to it. Change that. You can do it. Sit with your teacher and clear your doubts, and then tomorrow onwards, do a one single round of revision, which is more than enough to score 80 on 80. Trust me, it works. I hope you understood this clearly. Okay, perfect. So let's jump into organic chemistry once again. Which of the following belong to the same homologous series? Come on, you can answer this easily. Which of the following belong to the same homologous series? We have CH4. This is an alkane. C2H6. This is also an alkane. C3H8. This is an alkane. But C4H8, that's an alkene. So all alkanes belong to the same family, right? So it's 1, 2, and 3. So all of them belong to the same family, 1, 2, and 3. I hope it is clear. Okay, right. Now the next one. Which of the following belongs to homologous series of alkynes? Alkynes means it should be CnH2n minus 2, correct? So check out this C4H6. C4H6 is N is 4, that means 2n minus 2 will be 2 into 4 is 8 minus 2 is 6. So it is an alkyne. Then C6H10. So if you put N equal to 6, it will be 12 minus 2, which is 10. C6H10 is also an alkyne. C5H12. C5H12 comes as CnH2n plus 2. So this is going to be an alkane. So both A and B are the examples of alkynes. Okay, perfect. We'll do 2 more questions and we'll directly go to the quiz because the time is almost over. Correct formula of propanoic acid is. Come on, guys. Come on. Quickly answer it. Come on. You have all that fire now. With that, try to answer. Propanoic acid. Come on. Your thought process should go like this. Prop means 3 carbons. Oic acid means it should have a COOH group. So look for it. This is having 2 carbon. This is an ester. Then this is having 3 carbon and oic acid. Yes, so that's going to be the option. And this one is having an ester linkage again, CH3COOCH3. So the option is C. See how quickly the answer is coming when your mindset is a little bit tuned up. The final product of chlorination of methane in the sunlight is. You have studied substitution reaction, a very, very important reaction. Substitution reaction, saturated hydrocarbons when reacting with chlorine in presence of sunlight, you can see that the hydrogen atoms will sequentially get replaced. So if in the first step, when 1 mole of chlorine reacts, it will form chloromethane. In the second step, it will become dichloromethane. Third step, trichloromethane or chloroform. And then fourth step is carbon tetrachloride or tetrachloromethane, which is CCl4. In methane, all the hydrogen atoms will get replaced. So it's option D, the final product of chlorination of methane. You remember there is a statement in textbook that saturated hydrocarbons react with halogens in sunlight to replace each hydrogen step by step. That means if all the hydrogens in methane is replaced, you're going to see CCl4 as the final product. Right. So we have a couple of more questions, but I'll be sharing this in the group so you can solve those questions. Those are all easy stuff, and if you have any doubts you can ask as well. Now I just want to jump quickly into the quiz section. I want all of you to grab a device, a mobile, a tab or a lap or a computer, and then you can see on the screen there is a code. So you have to go to the website menti.com, menti.com, and then you have to enter the code 5634028. 5634028. 5634028. You can see on the screen. Explain the previous reaction? Yeah, sure. See, in the previous reaction, I told you about substitution. What is substitution? When an element comes and replaces another element. So you remember in methane, how many hydrogens are there? There are 4 hydrogens. And you add a chlorine molecule. What will happen is, one of the chlorine atom will go and replace a hydrogen. So, one second, 32 are joined. Right, yeah, so by the way, this CH4 plus Cl2, you will get CH3Cl, right? That is the only reaction which is given in the textbook. But you should remember, if chlorine is excess, in the next step, that CH3Cl will react with another chlorine to form CH2Cl2. That means one more hydrogen is replaced. Are you getting that? Finin and Anne-Marie, are you getting this? CH3Cl, which is formed in the first step, will react with another chlorine to form CH2Cl2. That means one more hydrogen is replaced. Then CH2Cl2 will react with another chlorine to form, I will write down here. First step is CH4 plus Cl2 in presence of sunlight will give you CH3Cl plus HCl. Then CH3Cl will react with another chlorine in sunlight to produce CH2Cl2 plus HCl. Then that CH2Cl2 will react with another chlorine to replace one more hydrogen, and you get CHCl3 plus HCl. And then finally in the last step there is one more hydrogen to be replaced, so that will be replaced by chlorine to give CCl4 plus HCl. So the final product of the halogenation is CCl4, which is also known as carbon tetrachloride. And Mary, is it clear? Finin, is it clear? Okay, right. So I can see 48 people have joined. I don't know what happened to others. I'm going to start the quiz because we don't have much time. So you can look into your device screen. Okay, you don't have to look into my screen. You can look into your device screen. So remember, the one who answer faster is going to get bonus points as well. So look into your device for the question. The first question: identify the unsaturated compounds from the following. You have 30 seconds, 9 seconds, 8 seconds. Come on, quick. Yes, time out. I can see 30 students have given the right answer. Unsaturated means it should be an alkene or an alkyne. Is it clear? So the right answer was D. Option D. Okay, here we go to the second question. Come on your screen. On your mobile screen. Chlorine reacts with saturated hydrocarbon at room temperature in the. We just learned that reaction. That's where we stopped. Come on, if you know the answer, you can answer quickly because that carries bonus points. Okay, majority have given the right answer. It is in the presence of sunlight. Okay, let's see what is the situation after 2 questions. Here is the leaderboard. Okay, Rahul, Arpendu, Nabiha, Arib, Namira, Shabnur, Utkarsh. Come on, yes. The next, we have 3 more questions. So let's jump into the third question. On your screen. Which of the following are correct structural isomers of butane? On your screen, guys. Yes, yes. So most of you have answered it correctly. Very good. Option C is the right answer. Let's go to the next question. All ready? Yes, Amal. Yes, Amal. Sure. We'll do it. Select the right choice. A student studies that acetic acid is a saturated compound. The structure of the compound is shown. Why is acetic acid classified as a saturated compound? It's a very important question, guys. Why is acetic acid a saturated compound? Look at the statements there and select your answer. Okay, most have given the right answer. It's option A, because there is a carbon-carbon single bond between the carbon atoms in acetic acid. That's why it is a saturated compound. Guys, you remember that saturated, it doesn't mean that the compound should have a double bond. It is a double bond. The compound unsaturated means the compound should have a carbon-carbon double bond. Remember, in acid, COOH, that C double bond O, that double bond is between carbon and oxygen. It's not between carbon and carbon. Is it clear? So it is a saturated compound because it is having only single bonds. Right. So let's move on to the last question. Here it is. Structural formula of benzene. Come on, I want everybody to make it right. Structural formula of benzene. My best bet is this year this question is going to come. Come on, all of you have to select the right choice. Yes, time up. So still, 5 or 6 have made it wrong, but majority have done it correct. Very good. So C6H6 is the formula of benzene. Okay, let's see who is the winner of today's quiz. Yes, Shabnur, Arpendu, Namira, Sean, Naira, Arib. These are the students on the top list. Shabnur is the winner today with 4,516 points. Maybe, Arpendu, you might have made all the questions correct, but the time, the response time also matters. So it's okay. Let's see more improvements in the upcoming sessions. At that time, we will see like if the scoreboard is going to change or is Shabnur going to stay on the top place. Right, guys, so I think now our time is over. Now we'll have another session, another wonderful session in biology. So in next class, in the next upcoming sessions, we will have more insights into some of the major topics in science. Right, so I hope, with today's class, more than organic chemistry or more than carbon and its compounds, I wanted you to realize that main point which I mentioned in between about the right thought that should be in your brain at least for these remaining days of for the board exam. So keep your positivity very high. Don't let any negative thoughts in your mind. Do not think that your future or you are going to get less marks or you're going to get underperform. Keep those things away. That is going to affect your performance. You work really hard, really smart, read the subject, have the understanding that I'm studying for so and so reason, I need to score really good marks, I want to get into the science stream, I want to see myself standing in so and so position. Visualize it that I'm going to be like this after 10 years, I'll be graduating from so and so college. Have this understanding and rest everything will work in favor of you. This is my promise, and it is going to work for sure. So keep a positive mindset, and we will see again in another session. Thank you guys. Bye.